It took some thought to answer some of the.
Yeah, of course. Yeah. Good. Well, I haven't looked at them yet, but yeah. Okay. There's a new one, as you can see, right? All right. Let's get started. We'll just start sort of where we left off, and let me share my screen. Okay. Hold on a sec. Hold on a sec, guys. Here's the. Where'd the cards go with the questions?
It's right here.
Oh, you have it. Okay. Don't forget. Sorry, he's got to get on his Zoom. All right. Okay, let me get rid of this and share my screen. Okay, so this is where we left off. We were talking about an inner product that is defined for matrices, for a vector space of matrices, right? In this case, the 2x2 set of all 2x2 matrices, right? And that this inner product here is that the inner product being, you know, if you have two matrices UV, that trace of U transpose B is an inner product. And this is what it ended up being, right here, when we actually calculated it for two matrices that we just made up, you know, these two, this one. Oh, hold on, my computer's doing its slow thing. Let me stop the share and share just that thing. I think that cures it. Give me a second. It means I have to just share that particular screen. Okay. See if that works. Okay. So, yeah, it's better. It's not great, but it's better. Okay. So we had these two matrices, and then we did the trace of A transpose B, and we ended up with this thing, right? Which is just, looks a lot like sort of multiplication of components if you have two vectors, doesn't it? Kind of look like that? Like at V1U1 plus V2U2, right? Or, you know, VXUX plus VYUI plus, right? So it looks a lot like that in the end. It looks really complicated when you see it, but you can probably imagine that this might make a good inner product. It certainly is a scalar, right? It's no longer a matrix because that's what it has to have, right? You have to have this operation on matrices that ends up giving you a scalar, right? Back. You have to have a number back. And certainly this will be a number, yeah? Okay. And the other axioms, right, that it has to follow is it has to be symmetric. What does that mean? That means that U, right, U, okay, pen, come on, U, V, right? This is the second axiom, right? I don't have it in front of me because I can't share it with you because of the way I'm sharing right now, but one of you can look at the theorem to remember for me and tell me if this is the second one, isn't it? Or maybe it's the first axiom. Okay, that's not right. Give me a second, see if I have it. No, I don't have it up here. I can get it up, but I can't share it with you because my computer will be too slow if I do that. So you guys are gonna have to look at it yourself. Okay, give me a sec. Yeah, so that is the first property. The first property that you have to obey if you're an inner product is you have to be symmetric, right? You have to be able to interchange these two, right? In the inner product and have it be the same thing. Okay. I want you guys to take the two matrices I defined here, and I'm going to write them out a little neater up here because they're a little messy because I was messing around, right? So we're going to put A is A1, and my pen is misbehaving, A3, A2, A4, and then B is B1, B3, B2, B4. And I want you, we did over here, we did this inner product, right? Again, my pen is being bad. They did this, you need to do B, A, and prove that it's the same as this guy, okay? And this is the definition, right, of, wow, what is wrong with my pen today? Okay, right? So you give that a try. And if you need help with like what is a transpose? Remember what is a trace, right? Just yell out, help you out. I'll be right back. Okay, Tyler, we're just working on doing this right here, the inner product of BA with this definition and this being B and A. Whoops, sorry.
Okay.
My pen is bad.
I thought we did that last class too. Or is we
Yeah.
doing?
We did AB. We need to do BA.
Oh, gotcha.
Prove this axiom, right?
Yep. Gotcha. Are we also proving that the axioms are true as well?
Well, this is one of the first axiom right here, right? This one is the first axiom.
Yep.
Right? So
Got
there's 4 others, but we're probably not going to prove all of them. But if you're done with this one, you should go on to the next.
Okay.
Prove that. Yeah.
Is there any real reason to transpose one of the matrices before you trace it?
We'll try. Why don't you try it without it and see?
It's just that it would come out the same either way.
Well, make sure.
Okay.
Yeah.
Yes, there is a reason to do it.
What is it?
You would get B1 get B1 A1 B3 A2 instead of B2
that's
A.
okay, right?
Not for the. It wouldn't be the same.
Yeah.
I get it. It's for the multiplication thing.
Yeah. $61 degrees outside right now in Lynchburg, guys.
It is going to start getting colder.
I'm gonna miss the birds.
Fine. It's been so long since it's been cool.
No, I'm not prepared for the cold.
I have 2 windows that are wide open, so I need to get rid of my AC units. So
Yeah.
I'm nervous to get rid of them because if it starts to get, this is
Yeah.
just a cold snap, then
Yeah.
I'm gonna suffer.
Yeah, and also it might be due to the fires on the West Coast, right? We've got some cover from smoke. We've actually
don't-
air quality lowered here, and sunsets are nice. Saw a great one last night. And then the it's covering, right? It's making things colder. So
It's just
that-
crazy how all of that even started.
I know.
Was it actually just one person? I still
I don't
haven't
think
figured
that was
that
for
part out.
one of the big fires, but it's not for all of the fires now.
Oh,
And
yeah.
obviously the one in Oregon wasn't started that way.
Yeah, there's like 71 different fires.
Yeah, so
That's a problem.
yeah, it's a really bad season, really bad.
One
Yeah,
of them. Oh, go ahead.
I was just saying it was just such a dry summer.
Yeah, and hotter from climate change.
Yeah. One of them was started by a dude who threw like a Molotov cocktail and he went to prison and then he got released from prison and he started 6 more after he got out.
Oh my God,
Oh yeah, smart.
that's just crazy. Yeah, the last time I was in Los Angeles, there was a fire, and that was in 2000. I want to say 8, 9, and I couldn't. I wanted to hike up to Griffith Observatory and couldn't. They had literally blocked all the trails because people were still going out trying to hike in these horrible conditions, but we couldn't do it. Yeah. How's calculation going out there? Oh, Tyler's done. Jackson, you're done, right?
Yeah.
Try to do the next axiom if you're done with this one.
What's the next axiom?
You guys have that paper. I can't show it to you right now, but let me tell you. It is if you have 2 vectors like u plus v inner product with w, they distribute inner product uw plus vw inner product. All right,
On like the theorems to remember sheet.
Yes, in the axioms, yeah. So it's like u plus v inner product with w equals u inner product with w plus the inner product with W. Yeah, that's the second one.
Did you want us to prove both sides of that? Like start doing the.
Yeah, if you're done with the first one, yeah. It's good practice in just dealing with matrices and how do you deal with matrices in the first place. So yeah.
And we're still using A and B from right here, right?
Yeah, these same ones. Uh-huh. So instead of UV, the only thing is for the second one, you got to make up a W. So make up a C matrix, right? And it's nice to put them into this form like I have. So like you can do C1, C2, C3, C4, like that. You can make up a C, because you need three different ones for the second axiom. Did you finish that second one, Tyler?
I finished all of them.
Oh, excellent. Good. Do you have any ability to write on the screen where you are?
I can, but it would take like a really long time because all I
Oh.
have is the trackpad of my mouse.
So you're just using the mouse. Yeah, okay, never mind.
Yeah.
I wish that Randolph should have like sent everybody like, pads and, pens, you know what I mean?
That would have been a lot of money. I don't know how public schools are doing it because they're sending like thousands of Chromebooks to students. That's
Well,
like,
they've always, but for like Lynchburg City Schools, it gives Chromebooks to everybody 6th grade and up. So.
oh, really?
Yeah, it's just their normal thing. Yeah.
Oh,
Not
We
kids.
just got missed by all that.
Yeah.
'cause-
right.
A lot of the schools started implementing them maybe like 3 years under us, because I know my brother was kind of the start of that.
Yeah.
Oh.
And they're starting to roll it out to the elementary school kids as well. But yeah, they don't get to keep them. They're not theirs. They just have them to take home with them for the semester, and then they give them back. And
I mean,
Yeah, I
that's
think
better than
my
nothing.
school, I think my high school was, or school district was just starting to get a Chromebook for each class, so that each class had a class set.
right, yeah.
The thing that kind of was curious though, that kind of came out of all that though, was, is it an invasion? Like some schools had different policies for like IT monitoring their Chromebooks, but with
Yeah.
Chromebooks going home with kids, like, is it the school's property so they can monitor everything that's going on the Chromebook, or does the kid have rights to have privacy on the Chromebook?
Right. Well, for sure,
That's been-
the Chromebooks block like everything.
Sure,
Yeah.
sure, but like I know like
at home.
overseas there were issues with like people looking at webcams to see if they were actually doing their work.
Oh wow. Yeah.
Yeah, and I think it was like in the Philippines there was a huge like
Yeah.
thing where they were like, that's not good, because the kids would just leave their Chromebooks open
Sure.
on their
that's
desk
not
in their
good.
rooms.
Definitely not good. Yeah, definitely not good.
So it's been curious to see some of the,
Yeah.
but
So how's everybody doing out there? Haley, where are you?
I'll be honest, I'm behind because I don't know how to trace.
Well, you should
So-
ask me.
I know, but I'm also seeing my tutor later, so
Okay. The trace is literally just the sum of the diagonals of a matrix. That's all it is.
oh.
Yeah. So if it
Well,
was the
dang.
trace of A, it would be A1 plus A4. Right? That's it.
Well, dang.
Yeah. Yeah. It's really easy. So you just have to do all that matrix multiplication first, right?
So what about transpose then?
Remember, transpose is just flip over the diagonal. Take a matrix and flip the numbers over the diagonal. Right?
So, oh, that's what that note was. Okay, sorry.
Yeah. So if
Okay.
you look up here at this A up here, if you do A transpose, you just say A transpose is, A1, and the diagonal stuff stays the same, but the other numbers are flipped. So there's A2 now up here and A3 down here. Make sense?
So
Mhm.
which is the symbol for transpose and which is the symbol for trace?
So trace is this TR,
Okay.
and transpose is the thing that you put on the actual matrix. Yeah? Aaron, how are you doing?
Working on it. I was close to where Haley was on that.
Okay. Well, you guys have to ask, okay? So you're not just sitting there. Okay. Zoe?
I finished the next axiom
Good.
and it proved right, like it should.
Good. Okay, good. That's good news. Well, let's give just another like 5 minutes, and then we'll go back to something else. So those of you who are done with all four, which I think is Tyler, and maybe I don't know if Jackson is done with all four yet. Done with all four?
Starting
yet?
on the 3.
There you go. Okay, so just keep going down the axioms, and yeah.
Dr. Shank, do you think we're going to go back next semester?
Wow, it's a big question. I don't know, I mean, no one's really talked about it yet. In meaning that I haven't heard anything from the college about it. Like, of course, people are talking, but I don't know anything about what their thinking is. I'm assuming that if things just continue to get worse, then that would be a no, right? Because right now, like Lynchburg, I think I watch the numbers pretty much every day, but like, we're still double digits every day. New double-digit cases every day, new cases, right? Which is like in the beginning of, was it the beginning of August? I can't remember, when we were in single digits for a long time, single digits per day, right? And then now it's double digits, and sometimes it's never been 3 digits, but it's been like 45 in a day, stuff like that. So I just don't know. I mean, so it's hard for me to say that, if, they think about when they closed, right? I mean, they closed in March, when there was, I don't know, maybe 2 cases in Lynchburg at all, right? I can't remember, but it was a very small number, right? It was really small, and they closed. And now we've passed 1,000 cases for sure, and are double digits every day. So I don't know, I mean,
I hope so, though.
I know.
Fingers crossed.
Yeah, fingers crossed.
Being online sucks.
Yeah, I mean, if, the only big hope, of course, is if we have a vaccine, and that, everybody can get vaccinated. That's the other thing. And of course, if we have a vaccine, that doesn't mean everybody can get vaccinated right away, right? Because it takes a long time to distribute and all that stuff. And, the first people to get it are not going to be 20-year-olds, right? They're going to be like older people and first responders, and, so yeah, I just don't know. We have a good amount of time, right? We don't start until like the end of January, right? So, which is good.
So they aren't changing the start date, even though we have technically a longer break?
I don't think they are.
Because we like have 2 months, I guess, for winter
Yeah, we
break.
have like a long time. Which
Oh
is
my
nice.
God.
I would be surprised if they did, just because usually those calendars they make like 3 years in advance.
Yeah, it's true. Although we did change this one, right?
Yeah,
They
it's not-
changed this one, and then
Yeah.
this one just was weird, but I could see them being like, the summers are long anyway, just getting it back on the normal,
Yeah, back on
like,
a normal
calendar.
thing, yeah.
because it matches the other private colleges too, if I'm not
Yeah.
mistaken.
I haven't seen any discussion about changing that date. So, but I don't know. They are talking about, faculty who, even if we are in person, let's assume that we are, that faculty can still opt out, and teach online. And that makes 100% sense, I hope, to you guys, because a lot of us are old. We're old folks. But let's just hope we're in a better position, I'm hoping. We got a lot of time. It's been pretty tough on you guys, huh, online?
It's been, it just isn't as fun and sucks.
Oh, no.
I find
Yeah.
it difficult to learn online.
Yeah, I
Yes.
know.
You have to be in the classroom.
I hear you. Yeah, I think that's very, very true. Just watching my kid who's, having first year of high school online, it's been terrible, honestly.
Yeah.
Because there's no synchronous classes at all. I think I told you guys, it's literally just, here's a bunch of stuff on Google Classroom for you to do on your own.
I will say that the synchronous classes help a lot, even if it's just once a week.
Right. Yeah, I totally see that. I wish they would. I know that they can't, because they feel like they would be shutting out so many students who don't have the internet, don't have the computers, even with a lab, even with if they have a Chromebook, if they don't have the internet, they're not going to be able to sit in class. So that's why they're not doing it. I understand. But like, he doesn't have any synchronous classes. There's none. So it's basically me homeschooling him,
I actually recently caught up with one of my old high school band teachers who's now doing like band at Salem High School out towards Virginia Beach, and it's curious seeing what the different like performance programs are doing right now too, because they're just like, well, we can't have a performance, and they can't, like, especially with the instruments, like a lot of students borrow instruments from the school.
Sure.
So he, I guess, like last week at one point, like went out and drove instruments to people's homes. Um, but it's just like there's not much the performing arts people can do, and they've also
Right.
had very little direction, which has been kind of curious
That
too.
is, yeah, it's tough,
But-
it's, even, I've been teaching online for a while, but, it's a different deal when the students are taking all online classes. It's like whole different thing. It's different when the students are taking like one class in the summer, like, it's just different. And so, we're all sort of learning how much work is appropriate, what's appropriate, what's not appropriate to give as, homework or whatever, you know what I mean?
I would like things to go back to normal, but I'm gonna have to agree. I kind of agree morbidly with what my dad says, that I don't expect anything to change until November 4th.
Yeah, true.
Like, I know it's kind of cynical, but
I know.
it probably has some grains of truth to it.
I hear that. It's a bad situation, and the fires and everything has made me pretty depressed. I have lots of friends in California. My dad is in California. It's just sucks. It's one thing after the other. Yeah, and I've been like coughing more now because of the smoke. There's literally smoke here. I was like coughing all day yesterday, and then I heard on the radio, oh yeah, our air quality's down by like whatever, 30 points, whatever that means. Because of the fires. I'm like, what? Okay. Anyway, let's do some more work here. So some of you got through almost all of the axioms, and some of you got through all of them. That's excellent. But you can see how this inner product, which is a weird looking inner product, right, is really an inner product. It really is, and it would work fine for any, space of n by n. Actually, you can have an a space of n by n matrices. This will work fine for, right? As you can probably imagine. Inner products don't have to look like that, 115 inner product that y'all know and love. Right? Let's take a look at another one. I'm going to get another layer. Come on, you're being very slow today. Okay. All right. So let's look at, we have, maybe another layer. There we go. So suppose, there's another example. Suppose we have, f is a vector, but what that means is that it's a function. So we're now in a space of functions. So we have f of x and another one, g of x. So another vector, g of x, and they're both functions which are continuous. On the interval a, b. Okay, so on this interval they're continuous. They can be discontinuous somewhere else, right? But on this interval they're continuous, both of them. Okay, so there is a vector space of continuous real valued. I should have said they're also real valued, meaning they're not complex, and they are real valued. This means that any x you stick in there, you're not going to get an I popping out of it, right? Not complex. So real valued. Remember, there is a vector space of continuous real valued functions on an interval, right? That is a vector space. We already sort of talked about it briefly. And we can define, let's define an inner product. Oh, pen, please. F, G, okay, as this integral A, B, F times G dx. Where the times here, we have to be explicit about this when we talk about this kind of thing. The times is the point-by-point times, right? So let's just give an example of what times means. So let's say f of x is, you know, x plus 2, and g of x is x, right? Then f of x times g of x, I put the times in there to be explicit there, is of course x plus 2 times x, which is of course x squared plus 2x, the usual you know, algebraic multiplication. And in the function space, it's literally point by point, right? Like if you had a point on the graph, you know, so here's x plus 2. Let's see, intercept is 2 here, right? There's f. My pen's misbehaving. And then, you know, you have some other, and then you have, you know, x. Sorry, they're supposed to be the same slope. Then to multiply, you would go like, okay, at this point, let's see, x equal 3 or something, right? You would multiply the function value of this one and the function value of this one, multiply those two, and you get a new function value, right? That's what you would do. That's the usual thing. That's the usual thing you do in calculus, or you're just not even thinking about it when you do it, okay? So that's what this multiplication is here. And that is, you do need to think about what is that, right? Okay. When you're writing down what an inner product is. We didn't talk about it, but when we define the inner product for those matrices, we're doing it with, in mind, matrix multiplication already defined somewhere for us, right? But really, it's being defined by the inner product. So I know that doesn't make that much sense, but you think about the trace of A transpose B, transpose has to be defined, A transpose times B in a matrix multiplication has to be defined, and the trace has to be defined. We just assume they were all defined. But when you're writing down an inner product, you have to be explicit in general, right? This is what I mean by matrix multiplication. This is what I mean by transpose. This is what I mean by trace. This is what I mean by two functions multiplying each other, okay? It's all part of the definition of an inner product. All right, so this is an inner product, and if you think about it, let's just go through one of the axioms. So let's look at G, F. And again, all the rules of integrals hold for this because I've written down an integral sign, right? So all the usual rules in calculus that you know hold. So we have g of x, f of x, dx. Well, clearly, if it's multiplication, right, of real valued functions, there's no reason I can't interchange these, right? So that indeed is equal to a f of x f g. Yeah? Number 2. So if you say, I have, you know, G plus, I don't know, W, inner product with F, then I'm going to have the integral AB, G plus W, oh, sorry, G of X plus W of X times F of X dx. And of course, by regular old algebraic manipulations on functions, you can show that this is the integral 0 to A, sorry, A to B, sorry about that, G of X, F of X, right, plus W of X, F of X, all dx, so this is all one thing here, which of course is equal to the integral A to B, G of X, F of X, dx, plus the integral to AB of W of X, F of X, dx, right? And that, of course, is the inner product G, F plus W, F. right? So now we've proven the second axiom. Again, there's all this machinery that you're assuming that in you when you define your inner product, that you are you probably should be way more explicit about, right? You should say, here's my inner product with the regular old point by point function multiply and under all the rules of normal integration, right? You should say that. Otherwise, you really can't prove these axioms, right? If you made up some other integral that has some other rules, you got to say what they are, right? Because you're free to make up whatever you want. And then as long as it satisfies all the axioms, you can use that as an inner product, okay? But so we have to be explicit here when we're defining inner products, because there's a lot of machinery that you're hiding if you don't explicitly say what that machinery is. Does that make sense to you, guys? Because couldn't you make up your own integral sign that does something different? Sure, you could. But you got to tell people what you're doing. So, okay. Number 3. Remind me what number 3 is. Who has the sheet up?
Inner product of c, some constant c times the vector u and v,
Gotcha.
some vector v.
Equals C F G. Yeah?
Yeah, equals c times the inner product
Yeah,
of f and g.
Okay, so let's try that. So we're going to do the inner product of C times F with G. C is just some number. And so I have the inner product of CF of X times G of X from A to B dx. Well, if C is a constant, because that's the part of the axiom is that C is a constant, a number like 3. I can just pull it out of the integral. And you have f of x dx, oops, sorry, g of x dx. And that's just c times the inner product of f g. Pretty easy. And the last one is this business about taking the inner product of f with itself, right? And so that is the inner product of, oh, we're right at class time. So let me just real quick finish this. Is f star, f with itself, which of course is the integral a to b of f squared, which is going to be, by the rules of integration, right? The area under that squared curve is going to be positive, right? Because you squared it. And so that's greater than or equal to 0 as far as we know. And the only really way to make this 0 is if f itself is 0, isn't that true? Because it's f squared. So the only way to make that integral 0 is f to be 0. Yeah, so this last one holds as well. All right, well, class is officially over. And we'll see you on, oh, we're not seeing you on Friday, remember? No class Friday. No class Friday, don't Zoom in.
Why don't we have class?
Oh, I have a thing that I'm going to. So yeah, I put it on the schedule. Put it on the schedule for a bit.
I had a question about homework.
Yeah.
Are you posting solutions for homework or?
Yeah, our solution. Oh yeah, so I didn't put the solutions up for it, but I will, like today.
Okay.
Yeah. Okay.
Okay, and one other thing, this is kind of off topic, but I'm guessing Marcus is canceled.
I think Marcus is online.
It's online.
Okay, so are we doing Marcus for the?
I mean, if you want to, yeah. You don't have to.
Yeah, I'd be willing to.
Yeah, do it. Yeah. I think you have to sign up, right?
Oh, I have to sign up?
Yeah, you have to sign up.
Oh.
Yeah.
Okay,
I think Sheldon put out a email about it.
All right, well, I'll try to work it out.
I think Dr. Courier and Sheldon sent out info on Marcus and the symposium.
Yeah. So look at that.
Okay. So,
If you email Dr. Sheldon, he'll help you.
Yeah, because he knows how to sign up for all that.
All right. Can you reach? Are any of the other guys in the? No, they're not here. So I'll try to reach out to them to see if they want to do it with me.
That's good. All right.
Okay.
Bye, guys.
Bye.
Dr. Shank, can I hold you after class and show you something cool?
Huh?
Can I hold you for a minute and show you something
Yeah,
cool?
go ahead. Sure.
Okay, talking about air stuff. So,